All right, so we're going to have a look at question 13 from the 2024 HSC Advanced Maths paper. This question is identical to question 22 from the Standard 2 paper. So the same solution pretty much work for both of them. So we have a animal population model. We are told the two variables are population W, population K. We are told the mathematical models which show their populations. And then we are asked to fill in a table of values. So we're told in 1985, the population of W is such that the A value is 34. Now, that's a useful piece of information because we know that the first model is now, so the model for W is actually going to be Y equals 34 times 1.055 to the power of X. Because that the A constant, that's actually a constant, the A and B. We haven't been told B. We do need to work it out though. So in this model, we just need to find the various parameters missing from these boxes. We can do this a few different ways. We can start by thinking about what the actual models are, and by finding the A and B parameters, and then by analyzing those equations, they'll give us the prediction values. So let's do that. So we've got A, now we need B. Well, in 1985, we can tell that population B, which is the one that goes down, was 280. And you can read that off the graph. So we know 280 is equal to B times bracket 0.97 to the power of, well, X is the number of years since, so that will be 0. This actually tells us that B should be 280. So we've got W, that's this model. We've also got K, which is Y equals 280 times 0.97 to the X. So we have A equals 34, we have B equals 280. Percentage change. Well, if we rewrite this top model, we could write it as 34 times 1 plus 0.055 to the X. This bottom one we could write as 280 times 1 minus 0.03 to the power of X. Now these are essentially compound interest models. The decimal being added to the 1 or subtracted from the 1 is the rate of change. So percentage change for population W is plus 0.055, which is plus 5.5%. And the percentage change for the population associated with the parameter K is minus 0.03, that's minus 3%. So these are the rates of change. The predicted population when X is 50, well, we're already told that for population K it's 61. You can read that off the chart. You can't read it off the chart for population W. So you have to plug in X equals 50 to the W model. So write the W model down here. We have Y when X equals 50 is 34 times 1.055 to the power of 50. So we'll plug this into the calculator. So 34 times 1.055 to the power of 50. That is, according to my calculator, 494.426 dot dot dot. So depending on how you round that, the closest rounding is 494. So we'll say the population estimate is 494. So that is how you get the missing parameters for question 13. The working here is the same for the advanced maths course and the standard maths course, right? It's just studying exponentials and then analyzing the formulas you get based on formulas and graphs.